In this problem, we are going to solve for x. The difficulty lies in the fact that x is in the exponent, and isolating that will require us to be creative. In this case, I'm going to use what I've been calling the common base method, or you could call it the same base method. That's where we want to look directly at the base of each expression involved, which has x in the exponent, and try to figure out what we could write those in terms of so that they'd be the same. So here I'm exploring 32 and 1/16. It's a little easy to get overwhelmed by the fractions, but 32, in terms of a power, I could rewrite that as 2 to the 5th. 1/16, it might be better to just think of 16 at first, and remember that that's just 2 to the 4th. So when you see something like 1/16, that'd be 1 over 2 to the 4th, which could be easily rewritten as 2 to the negative 4th. Migrating that base 2 upstairs would just change the sign on the exponent. So we're going to want to substitute 32 and 1/16 out in exchange for 2 to the 5th and 2 to the negative 4th, and we'll see how that looks once we do that. So I'm going to kind of place the structure of what's already on both of these numbers first, and then we'll, with surgical accuracy, substitute in the 2 to the 5th and the 2 to the negative 4th in lieu of those two original bases. Now we haven't changed anything in terms of value. Everything's still very much equal here because 2 to the 5th is 32 and 2 to the negative 4th is 1/16. We're just changing the way it looks so that we get this common base, this base 2. Okay, so we need our exponent properties now. We've got power on power, so we're going to be multiplying, and you'll need to remember on this right side here to distribute as you multiply. So we'll end up with 2 to the 5 times x over 5. Well, that's just 5x over 5, which is just x. So we'll have 2 to the x equals, and then on this side we'll have 2 to the, distribute the negative 4 through that expression, and you'll have negative 16x plus 12. Okay, so this is magical. Now that we have a common base on both sides, that being 2, what this method allows us to do is focus on, if the bases are equal, then the exponents must be equal. And this goes for if I have a single term on the left and a single term on the right to the exact same base, then those powers have to be equal. So we're just going to jump out of the problem here and solve the equation, the equality of those exponents. And this might be a little underwhelming because this is just linear kind of algebra 1 stuff here. Add the 16x to both sides. That doesn't go too bad. Now we have 17x equals 12, and solving for x will finally divide off that coefficient of 17, and we end up with x fully isolated equals 12/17. Alrighty, so that means if you were to reevaluate this thing with 12/17 in for x, these things should in fact be equal. So the exact answer here, without losing any digits of accuracy, would be 12/17.